Here's a simulation of molecular behaviors made with interactive physics. These are molecules. This is an H2 molecule. Hydrogen atom bonded to hydrogen atom makes H2, diatomic. There are 6 different molecules in this simulation. This is illustrating the behavior of hydrogen gas molecules. You can see they drift, and when they collide with each other, they simply bounce off. They're not attracted to each other. They're not repelled from each other. They're simply bouncing off when they collide. And this is the behavior of most gas molecules. They drift without real purpose until they collide with something, and then they bounce off. Now we have hydrogen gas molecules, but there are these added blue/red molecules, which, as the title implies, are polar molecules. Polar molecules, you'll recall, have delta plus and delta minus charges, partial charges. This affects their behavior. So here you can see the polar molecules are attracted to each other. Specifically, this red atom is attracted to the blue atom of a neighbor. There are still 2 molecules. They have not become one, but the 2 molecules are friends, so they like to stick together. Hydrogen gas has no such attractions between molecules, so they drift aimlessly. So this attraction is called an intermolecular attraction, an attraction between the molecules. I will tend to call this a friendship bond. They like to stick together. Here are the same molecules for hydrogen molecules and 2 polar molecules, something perhaps like HF. But in this case, the temperature is higher. So here, you can see the polar molecules have joined, but they're unable to stay together. At this higher temperature, the molecules move too quickly, and the collisions are too violent for the 2 polar molecules to remain attached to each other. So this suggests that the interaction between the 2 polar molecules, the intermolecular attractions, are not all that strong. At a high temperature, those interactions are disrupted, and these 2 molecules are behaving like gases. Here is a representation of 2 molecules. I've labeled them molecule A, molecule B. They're both HF, and HF is a polar molecule. The electronegativity difference between hydrogen and fluorine is 1.9, meaning the hydrogen will be slightly positive, the fluorine will be slightly negative. That's what it means to be a polar molecule. We have delta plus and delta minus. There will be an attraction, which I'm hoping you can see. This delta plus hydrogen from molecule A will be attracted to the delta minus fluorine of molecule B. We need a special symbol for that. That special symbol will be 1, 2, 3 dots. That should look to you like a kind of attraction. There is an attraction here. It's an intermolecular attraction. And this symbol of 3 dots is used by chemists to represent such an attraction. It's not a very strong bond. It's not at all like this line here that's a covalent bond. That bond is very hard to break, but this intermolecular attraction, they're just friends. It's not a permanent bond. This type of friendship bonding or intermolecular attraction has great implications in the behavior of molecules. The title of this simulation is Forming a Raindrop. This represents a water molecule. 2 hydrogens bonded to an oxygen makes H2O. There are 4 such molecules in their proper V shape. Water molecules are polar, which means there will be attractions between molecules, intermolecular attractions. You can see the molecules clustering together. And when molecules cluster together like this, they're still somewhat wiggly. This is a liquid. So this is what it means to form a raindrop of liquid water. When they're separated, they're gas. When they cluster together, that's a phase change. The change of gas to liquid is sometimes called condensation. These molecules have condensed to form a liquid. And that liquid will fall to earth and land on someone's head, and they'll say, "It's raining." So the intermolecular attractions make it possible for water vapor to easily form liquid. We can run this process in reverse. So here's the liquid water getting warmer, separating into individual molecules, and that is called evaporation. The reverse of condensation is evaporation. These molecules would be free to go separate ways as gas. Here's a water molecule, and I'll draw a second one so that they can be attracted. So here's the oxygen, here are the hydrogen atoms. Got that nice bent geometry, 105-degree angle between them. And polarity makes them so that the molecules will be attracted. This oxygen is delta minus, hydrogen's delta plus, each one of them. And you should see between this hydrogen here and this oxygen here, there will be an attraction. Delta plus attracts delta minus. We represent that with 3 dots. These dots should be erased. That's a very important picture. This intermolecular attraction between water molecules explains many of the behaviors of water. It is called a hydrogen bond. So a hydrogen bond is a special kind of friendship bond that holds these water molecules together so that they can easily condense to form a liquid.